Okay, class, picking up where we left off at from the last video, we have this hint here. It says if a system contains fractions, first clear them by multiplying by the least common denominator. Example 3, use either substitution or elimination to solve the following. Now we look here. First, let's clear out these fractions. The common denominator of 2 and 4 is 4, so we'll multiply everything by 4. And then the second equation, the common denominator of these 3's is just 3. So now, when we multiply everything by 4, this will give us 2x minus 3y is equal to negative 16. Now we multiply this whole equation by 3. This will give us 2x minus y equals negative 12. Now remember, you must multiply everything, each side of this equation by 3, each side of this equation by 4. Now, I think it would be easier to use the elimination method since we have the same coefficient for the x's. The only thing we need to do here is just change the sign. So what I would suggest is let's multiply the first equation by negative 1. So now we would end up with negative 2x plus 3y equals 16. And we'll write down the second equation. Now these two x's will simplify out. 3y minus y is 2y, and it equals to 16 minus 12, which is 4. We divide each side by 2, and y is equal to 2. Now we have to find our x value. Now we could use one of these two equations. We do not have to use one of these two originals. We could use one of these two after we got rid of our fractions. So I would suggest let's use the bottom equation. So we had 2x minus y equals negative 12. So we had 2x minus 2 for y equals negative 12. Now we can add 2 on both sides, and we will have 2x is equal to a negative 10. Now we would divide each side by 2, and x is negative 5. So our final answer, our final order pair would be negative 5, 2. And that is the solution and also their point of intersection. Now we go down to the last problem. We have decimals here. Now with decimals, we could get rid of decimals by basically multiplying by a power of 10. So what we could do is this here. If you do not like working with decimals, you look in your equation and see which one has the most digits behind the decimal. If you look here, the most digits behind the decimal in this first equation is 2. So we can multiply this whole equation by 100. The most digits in this equation here is 2 behind the decimal, so we can multiply this equation by 100. So this would give us 100y is equal to a negative 425x minus 219. And in the bottom, we will have 100y is equal to, we will have 365x plus 938. Now, what I would suggest that we do is this here. Now, we can do the elimination method by moving the x values over. So, what we could do is this. We would take our 100y is equal to a negative 425x minus 219. We could add 425x on both sides. So we will have 425x plus 100y is equal to a negative 219. Now we would do that with the second equation. We know we're going to subtract 365x on both sides. Okay, and once we do that, that will give us a negative 365x plus 100y is equal to 938. Now, the easiest thing for us to get rid of is the y's. So what we could do is I would take this top equation and multiply it by -1. So the top equation would give us negative 425x minus 100y is equal to 219. And we'll bring down that second equation. Now we will add these values. A negative 425 and a negative 365 will give us a negative 790x. These y's will simplify out, and then we will add these values here. This will give us 17.5. So this will give us 1,157. Now we would divide each side by a negative 790. And our answer here would give us, let me scroll down a little bit for some space. This would give us x is equal to a negative 1.46. Okay, now that we have our x, we need to solve for our y. It doesn't matter which y that we use. So let's try the first y. Okay, so we would have y is equal to a negative 4.25x minus 2.19. Okay, now we would substitute in what we got for x, which was a negative 1.46. So we had negative 4.25 times a negative 1.46 minus 2.19. So we have y is equal to, now first of all, we know a negative times a negative is a positive. So negative 4.25 times a negative 1.46 minus 2.19, that would give us y is approximately, rounded to 2 decimal places, will be 4.01. So we have y is a positive 4.01, x is a negative 1.46. So our final answer here would be a negative 1.46, comma 4.01. And this is our final answer.